tuning in for this Trail of Bits workshop. Thank you all for coming. Hello, hello. Welcome to this Trail of Bits workshop. We're being all very punctual today, but nice to see you all. I'm Eleanor. I'm the main organizer of ETHDam. You'll see me walking around during the conference and hackathon. I'm the pregnant lady, so you can't miss me with purple hair. But I really look forward to welcoming you all during ETHDam in a week from now, which I can't believe we're already at this point. But I'm really happy that you're all here today, curious to learn more about Trail of Bits. They will be a canoe sponsor for ETHDam, and they will have a 2K bounty to offer to all of you. So this is really smart of you, for all of you to join this ETHDam bootcamp. We want to make sure to give you as much information in advance for you to learn as much as possible today. I'll give the stage very fast to Jocelyn for him to tell you more about Trail of Bits itself. For anybody who wants to stay on after the workshop, we'll facilitate as long as you want it. If you want to do a bit of team building, if you want to get to know other hackers. But yeah, thank you so much already for tuning in. And without further ado, Jocelyn, this is your time to shine.
Thank you for the introduction. Okay, let me share my screen. And let me go full screen. Okay, first question first, can you see my screen?
Yes, I can see your screen.
Perfect, okay. So welcome everyone. Welcome everyone to this presentation on Slater. So during the hackathon at ETHDam, we are going to have a 2K prize for some of the best kind of project built on top of Slater. So we wanted to take the opportunity of this workshop to give you some kind of walkthrough of our API and how to use Slater, what it is, what you can do, so that you can be a bit equipped before the hackathon to understand kind of like the capability of the tool. But first thing first, who am I? My name is Jocelyn Feist. I'm the engineering director of the blockchain team at Trail of Bits. If you don't know us, we are a security company where we specialize in high-end security technology. We work on blockchain, but we also work on a lot of different areas, such as traditional application security, cryptography, machine learning. One, I think, of our kind of specificity is that we specialize a lot in program analysis, and we always try to apply research in our day-to-day activities. As a result of that, we have built many open source tools that you might know, such as Slater, Echidna, Medusa, Caracal, and so on. But as I mentioned, today we are going to focus on Slater, and the reason for that is that we have a 2K prize for Slater at the hackathon. So during this presentation, we are going to see what is Slater. We are going to see its internal, its API, its intermediate representation. And really the goal for you is at the end of this presentation, you will be able to have some high-level understanding and some kind of points on how to start, how to build on top of Slater, what you can do, what are kind of like the capabilities. Feel free to stop me at any time if you have questions. This is going to be a bit dense. It's going to be a technical walkthrough of the capabilities. So if you have any question, I can stop, and this can be interactive if you have any need for that. Okay, I've been talking about Slater for 1 minute now, but what it is. You might have used Slater in the past as a Solidity developer or a security engineer. Slater is a static analysis framework for both Solidity and Viper. What it does is that it provides a lot of analyses that are kind of out of the box, such as vulnerability detection, optimization detection, but it goes beyond that, and it allows people to kind of improve their understanding of a code base, and it allows kind of custom API to build additional tools on top of it. Slither is open source. It has been developed for probably 5 years-ish now, and you can see the code here. It's in Python, so yeah. On a really, really high level, if you think about Slither, its architecture is kind of close to a compiler. The way it works is that it's going to take the output from a compiler, Solidity compiler or the Viper compiler, is going to do a couple of analysis on top of it to retrieve some information, to build its own intermediate representation, which we are going to see later. It does a couple of code analysis to kind of find some information, and it provides all this information, all the result of the different analysis to the different modules from vulnerability detection, optimization detection, printers, and kind of third-party tools. So I think 90-ish% of the people that use Slither mostly use it from the command line to find vulnerability. If you have used it in the past, you might know that it comes with inbuilt detector. So right now we have more than 90 public detectors that are available for everyone, from high severity to optimization. It really runs from everything we have found during our security review and our audit, and we are kind of constantly improving the detector. Slither has a proven track of vulnerability found. Just by using the tool, you can see the Slither trophy page on our GitHub, where we just list like some of the vulnerability that we know about that were found just using the tool. Through this presentation, I'm going to give you a couple of kind of cheat sheets just to understand some of the most common command line, most common API for you to use. When we talk about detectors, the first one to know is Slither list detector. Basically, it's going to just show you like all the detectors that are available. If you want to run a specific detector on a target, you just run Slither, the target -detect, and the detector name, which is straightforward. One thing that you might know is that all the vulnerabilities that are going to be found by Slither might not be real vulnerability. You might have kind of false alert or false positive. So part of the work when you use Slither in a code base is to triage the result of the detector. To do that, there are a couple of techniques. The first one is to use code commands in Solidity to disable the detector. So the first one, Slither disable next line, you just disable the next line for a specific detector. You can also use it from like a code command where you have a start and an end. I'm going to give an example in the next slide. And if you want to triage some specific vulnerabilities, such as reentrancy, we have a couple of additional techniques, such as using custom knapsack command. I'm going to give an example in a few. So here we have a piece of Solidity code. There is a reentrancy vulnerability in this code. And let's imagine you don't care about this vulnerability and you don't want Slither to warn about it. Here you can use a code command where before and after the function, you declare Slither disable start, Slither disable end with the name of the detector. So this is just going to tell Slither to not report any reentrancy in this function. Obviously, don't do it on a real positive, on a real vulnerability, but it's just to give you an example on how to triage it. I did mention that we have kind of custom command for some of the detector, in particular for reentrancy. So when you kind of start to triage reentrancy alert on a large code base, you might end up in a situation where a lot of false positives comes from a contract or like a variable, which can do external call, but you are kind of sure that this external call are not going to be reentrant. For example, if you have an ERC20 token and you call the transfer function, depending on the implementation of the ERC20 token, it might have external call or not within the transfer function. If you know that the contract is not reentrant, you can add kind of this custom comments right before the declaration of the variable to tell Slither this is not a reentrant contract. You don't need to tell me about reentrancy related to this variable. Another way to triage a result is to use the interactive mode. So Slither, the target, -- triage mode. This is going to create an interactive mode where for every vulnerability, you can discard and kind of create a database that will kind of include all the things that you have triaged. So that every time you run Slither, you will kind of discard the thing that you have already kind of triaged. This is useful, for example, if you run it for the first time, you discard everything which is not relevant, and then you can keep running Slither on top of it. Now, the best way from a developer standpoint to do the triage, I think, is to use a GitHub action that we provide, which is also open source, which is integrated within GitHub. So as you can see in the screenshot, you have code scanning from GitHub. You have like a nice interface to triage the results. It's just a bit kind of easier to triage Slither results through GitHub than through the command line. In addition, this can be included in the pull request process. So you can have Slither that runs on every pull request and give you warning when there's something happening. One kind of features and flag that is also useful is a filtering path. So here you can tell Slither to ignore specific file or specific directory. Under the hood, it's going to use Python regular expression. So this is going to be useful if, for example, you know that there is a directory with mark contra and you don't care if there is like vulnerabilities in the mark contra. So you can just tell Slither to ignore this path with filter path. When you run Slither, you need to provide a target. And this is where I think a lot of users are sometimes a bit confused and don't know exactly how to navigate this. The target needs to be something that can be compiled. The first use of it is to run Slither on a Solidity file, so Slither file.sol. This is okay, but it's not the most recommended kind of a way of using it, because from the moment your compilation will require real mapping, it is going to be a bit tricky and you might need to add additional flag. Kind of like the idea is that if you can run solc with a file, you can run Slither on top of it, but if just by running solc directly on the file, it doesn't compile, most likely Slither is not going to be able to compile it out of the box without additional remapping. Here, the kind of recommended version is to use compilation framework, which most of the people are using, where target is not the file that you are kind of analyzing, but the root directory of the project. For example, if you are on a Foundry project or Hardart or Truffle, you just need to run Slither on the top directory. If you are running Slither from the top directory directly, you just run Slither dot being the current path. We do have a couple of extra support for Foundry. So if you are on the top directory and you run Foundry with a Solidity file, Slither is going to try to figure out the remapping automatically with Foundry, but sometimes might not work depending on the complexity of your remapping. Another feature that I'm not sure a lot of people are aware about Slither is that we can directly analyze contracts that are deployed as long as the code is on ETHDam or on any ETHDam-like platform. To do that, really simple, Slither, and instead of providing a file, you provide an address. These support most of the testnet, most of the layer 1, layer 2 that are EVM compatible. For example, we support Arbitrum, we support Optimism, Binance, Base, and so on. You just need to say Slither, the kind of keyword of the network, and the address, so that you can kind of run Slither directly on top of things that are deployed on chain, as long as the code is verified on EtherScan or EtherScan-like platform. Okay, before I go to the code understanding, is there any question regarding the detector?
We do have a question in the chat.
Okay, let me try to find this.
The question
okay,
is, oh, go ahead.
So the question is, does Slither works with a diamond standard, working with diamond and facet? Yes, it works out of the box on any kind of like standard platform as long as it's Solidity. We don't have a specific support for diamond standard, but we can analyze the code base without any problem. So the second question here is, where does ETHDam come from? That's a long story, but short. We started with Solidity Analyzer. Then we wanted to have something related to animals or mythology. And that's where we ended up with something related to a snake and Slither. Okay, the next question, target audience, is it useful for all level of developer? I think it's useful for all level of developer. Part of the presentation is going to be a bit more a deep dive, so it's probably going to be more useful for intermediate developer, but the first kind of half of it might be for everyone. Okay, next question. What do you expect from us during ETHDam? So we are going to have an hackathon, and what we kind of invite everyone to try is to try Slither and to build a project on top of it. We are going to give a bit more details about the theme that we are looking for people to work on, but it's going to be things like integrate Slither in some kind of interface, or kind of combine Slither with machine learning, or this type of things. But more details to be shared soon. Okay, next question. Does Slither contract verification download work with Block Scout Lite Explorer 2? That's a good question. I'm not sure we support Block Scout, but we could add the support. So basically, it works with any kind of ETHDam-like platform, any kind of web interface where you have the source code and we can query it, we can add the support for it. So for example, we support, as I mentioned, Arbitrum, like the Arbitrum Explorer, the Optimism Explorer, the Binance one, I forgot the name of the Explorer, and so on. Where do you get the URL from the Explorer? They are hard-coded in Slither. Yeah, if OASIS is not, we can definitely add it. But it might already be there, to be confirmed. Okay, I'm going to go back to the presentation. Okay, so as I mentioned, I think 90% of the people use Slither just through the detector, but we have actually a couple of additional features. The first one are the so-called printers. So printers are visual representation of the code, and we have kind of a bunch of different visual representation. The one you are seeing on the right side here is the inheritance graph. If you have worked with complex Solidity code base, you know that developers tend to heavily use inheritance, and you end up in a situation where contract A inherit from B, inherit from C, inherit from D, and it might be difficult to navigate kind of the inheritance tree of a code base. So here is where kind of like this visual representation can help. We have other ones, such as a human summary, which is going to give you like a really high-level summary of the contract. Is it upgradable? Does it follow any ERC, and so on. We have a couple of them that are a bit more in-depth, that are a bit more kind of complex. For example, vars and out is going to give you a table with all the variable and the different authorization and access control of a function. So for example, if a function with some like a specific variable and has an only owner modifier, it's going to highlight it. Similar to the detector, to list the printer, you can just run Slither list printer, and to run a printer on a target, Slither target dash print and the printer name, which is straightforward. Okay, but the part where I want to go today is really more about not using Slither from the command line, but using its API to build tools and to kind of hack on top of it. And this is where Slither, being a generic static analysis framework, is going to be useful. So when I say generic static analysis framework, Slither is basically a tool on top of which you can build a lot of things. And here is just a couple of examples of additional tools that we have built that are also open source and comes with Slither that just rely on this API. For example, Slither read storage. So this is a tool that is going to allow you to read the value of a variable on chain. And the way it works is that Slither is going to query the source code, for example, on Etherscan. It's going to figure out what's the storage layout of the contract, and it's going to query an RPC node to get the value. So this is like an example of kind of API that you can build on top of Slither. We have other things, for example, Slither check upgradability, which is a specific tool to review delegate call-based proxy vulnerability due to the upgradability. We have also Slither check ERC. You give this contract, and it's going to check for ERC conformance. ERC conformance, for example, if you say, okay, I'm building an ERC20, it's going to check if you have like the proper function, if you return the proper parameter, and so on. So it's kind of like a conformance check. But as I mentioned, all of these tools were built on top of Slither using the Python API. And what we are going to see now is how you can leverage yourself this API. Just to give you a really kind of quick example, if you want from a code base to know what function can modify, a state variable. You can do that in 5 lines of code. Here, you provide Solidity 5. You kind of work through the contract, the name of the variable, and you ask Slither what are the functions that can write this specific variable, and Slither is going to tell you. Okay. So how does it work, and how can you kind of leverage that? The first things to understand is that, as I mentioned at the beginning, Slither takes as input the IST from the compiler. IST is an abstract syntax tree. It's a common representation of the code base that the compiler, both Salty and the Viper compiler, provide. Just to give you an insight, what does it mean? If you take like this Solidity code, the IST representation is like the tree on the right side. It's basically just going to have like every operation is going to be a node, and you can kind of walk through that, and the leaf are going to be variable in kind of simplification. This is a really common kind of representation in static analysis. From that, Slither is going to provide a couple of layers that we are going to see now. Basically, a 5-layer compilation unit, contract, function, control flow graph, and expression/intermediate representation. The first thing that you have to do is that in Python, you have to create a Slither object. To do that, you import from Slither, import Slither, the Slither object, and you create by providing the target. Now, the target here can be anything that we already described on the detector path. It can be a file, it can be a project, or it can be a contract which is on-chain. For example, here you can see kind of at the middle of the slide, I'm creating a Slither object where the address is the address of the USDT token on mainnet. Some things to know is that if you start doing that on a bot, or if you start doing that, like you run it a lot of time, because it query EtherScan, you might end up reaching the EtherScan key limit. So you can also provide to the Slither object an EtherScan API key, which is just going to allow you to make more queries. So EtherScan API key is free, but you need to register on EtherScan. This is just if you do like a lot of query to different contracts, or if you build a bot, you will probably reach the rate limit of EtherScan. Okay, the first layer that we're going to talk is a compilation unit. A compilation unit is really a group of files used by one call to the compiler. Most of the time, most of the targets that you are going to analyze will have only one compilation unit. But it's not always true, because depending on the compilation framework, you might have partial compilation for optimization. So maybe it's only going to kind of analyze a couple of files. Or if you use multiple Salty versions, for example, with Foundry, if you have like one Solidity file with Solidity 0.8 and one other with Solidity 0.7, this is going to create multiple calls to the compiler. So this is going to create multiple compilation units. How to access them? You create a Slither object with a target, and then you can do the Slither object dot compilation units, which will return an array. Why does this matter? Because when you're going to go through the APIs from Slither, some of the API might not be intuitive because of this notion of compilation unit. It's something which is needed from the architecture standpoint, but might be a bit confusing at first. For example, if you are looking for a contract based on a name, you can actually have multiple contracts with the same name, and frequently if you have like multiple compilation units. So this is something to keep in mind. However, if you are hacking on top of Slither, if you are doing like a quick proof of concept and you just want to be really fast, you can probably just assume there is one compilation unit, and from the array just take the first element. So Slither object.compilation unit, and you just take the first element, which is at the 0 offset. Now you have this compilation unit object, and you can do a couple of things. The first thing you can do is that you can list all the contracts from this compilation unit. The second one, which is contract derived, here it's going to list all the most derived contracts. So a most derived contract is a contract which is not inherited anywhere else in the code base. This notion is important because sometimes you want to kind of explore all the contract of a code base, but sometimes what you really want are all the leaf in the inheritance tree, because it's usually where you have like most of the logic which is implemented. Another function which is useful is get contract from name, which is straightforward. Then you can also access all the top level objects: structure, enum, events, variable, function. Top level follow Solidity in the sense that these are like the objects that are not declared within the contract, they are declared outside of the contract. To give you an example, so here we are creating a Slitter object with the USDT address, and then we print all the contracts that are at this address, and we also print just after that all the most derived contract. And if you run this, you will see like the two difference. Like the first one, you have like a lot of contract, and if you look at the most derived, you only have 3 of them. For example, ERC20 or ERC20 basic are going to be inherited by the Tether token. As a result, they are not in the most derived contract. So here, if you look at the code base which is deployed, you will see like SafeMat, upgrade standard token, and Tether token are the most derived one. Okay, then we can go one step further. So from the compilation unit, we can start exploring the contract. From the contract, you have a couple of methods that are going to be useful for you. The first one, the name, which is straightforward. Then you have the inheritance. So the inheritance is going to go in both sides. Directly inheritance is going to be all the contract that this contract inherits from. Something to consider is that here we follow the C3 linearization order. If you don't know what this is, if you don't know what the C3 linearization order is, I highly recommend after this presentation to look it up. It's basically the way Solidity is going to deal with multiple inheritance. It's a concept which is important if you kind of want to become a bit more advanced in Solidity. Let's say just here, Slitter just follow this order. Derived contract goes the other way around. You can know which contract are going to inherit from the one you are looking at. So basically, you have an inheritance tree, and you can go back and forth in the tree. You have also a bunch of general object, enum, event structures. So this one are the ones that are declared within the contract. Now for the state variable. Here you can directly access state variables, which is going to be the list of accessible variable. Accessible because within Solidity, a contract might inherit from another one, which has private variable. Private variable are not accessible from derived contract, so you will not see them. Again, like here, we are trying to follow like the Solidity convention. If you need to access everything, you can access them with state variable order, which is going to give you all the variable ordered by the declaration. Finally, get function from signature. Yeah, pretty straightforward. These are just some examples of the API. If you go to the contract.py or if you go to the documentation, you will find other API, but at least this one gives you kind of like the boilerplate to build on top of it. So in the following example, every time there is kind of a red box, it means that everything above is just the same code as the previous example. So like the first line is to import Slitter, second one to kind of create an object from the USDT contract and the compilation unit. Again, same thing that we were doing before. Now the difference here is that we are printing from the Tether contract, the USDT contract, all the state variable. And if you run this, you will see that. So this is all the state variable on the USDT contract. I think you can already kind of have the insight that in a 5 line of code, you can start playing with some of the information on the USDT contract. So you can start kind of building on top of it, and you can start navigating what are the variable, what are the contract, and doing back and forth with that. Now we can go one step further. So we have contract, we can go into function. Some of the APIs that are going to be useful for navigating with function are here. The first one, Solidity signature, pretty straightforward. Entry point, which return a node. We are going to give a bit more details about what's a node and the control flow graph in a few, but just to give you kind of information that this is already accessible from the function. Elements, you're going to have expression, variable, node, modifier of the function. Then you have a couple of operations that you can access from the function. For example, you can access all state or local variables that are read or written. So if you want to know, like, is this function really reading a specific variable or writing a specific variable, both local or state, you can access this just with this kind of function. All of them, state, local, read, write, can be prefixed by all. If you prefix them by all, it basically does a recursive lookup, in the sense that instead of just looking at the scope of the function, you are going to look at the scope of the function and all the internal codes. I have an example just after, just to make it a bit more clear. And then additionally, you can iterate over the split IR operation, which we are going to see later. So a simple example. Again, the first 4 lines are exactly the same as before. We fetch the USDT contract, we fetch the USDT contract. So now what we are asking is that we are asking to print all the state variables that are read by the total supply function. And to do that, we call get function from signature, the signature of total supply, and we just print all the state variables that are read. If you do that, yeah, basically 3 state variables that are read on USDT, total supply function. But as I mentioned, we have kind of, for this type of operation, we also have a version with that starts with whole that you can see here, like the first variable, the first print operation is going to print all the state variables that are read by the transfer function, and the second one exactly the same, but including the inner call. If we look at what is kind of shown here, is that here, when you run this piece of code, you can see that the version that is recursive with the internal call does show a lot more variable. So reason for that is that if you look at the transfer function on USDT, it has 2 internal calls. The first one is a modifier, when not pause, and the second one is a call to the super.transfer function. Kind of like the idea here is that based on what you need to use a proper API. If you just look at the scope of the function and you don't care about what's happening in the internal call, you can use a normal API. If you want to have something a bit more broad and consider everything which can be done by the function and its internal call, you can use all underscore the name of the property. Okay. The next concept kind of to understand it is going to be useful for any static analysis is the notion of control flow graph. A control flow graph is a really common code representation for static analyzer and compiler. Basically, you take your code and you represent it as a graph. Nothing magic here. You can see the example on the left side and on the right side. Here, there is no loop, there is no for loop. If you have a for loop, you can have an edge that comes from like one point and go back to an inner node. Basically, it's a control flow graph because it's a graph that represents what are the different control flow of the code. Control flow being condition, loop, and so on. Why this matter is that depending on what you're going to do, that if you want to build complex analysis, you will need to iterate over the node of the control flow graph. If the order of what you are doing doesn't matter, you can just iterate over the list. So you have function.node, which is a list of all the nodes. You can just do for node in this list. Now, if you start building more complex analysis where the control flow is important, you need to work through the node. Here, I just give kind of a snippet of code, which is a kind of a standard way to work through the node using a visit kind of pattern. So you define a node where you want to kind of explore the node that you have already visited, and if you already visited them, you just stop. If not, you go do some custom action and you recursively call the same function over like the son of the node, so over like the node that are after this one in the control flow graph. Now, if you start building complex analysis, which is going to require a bit more kind of consideration, you might need to iterate multiple times over the node in the control flow graph. So here you have to be careful because you are kind of iterating over a graph, you can have an infinite loop. Like you can go over and over and over and never finish. To avoid that, you have 2 strategies. The first one, you just bound the iteration and you say, I'm going to recursively call this function with this parameter until some time. Or you can create a so-called fixed point where basically you can say, I'm iterating until I'm not propagating any new information, which is kind of similar to abstract interpretation or like more traditional control flow analysis if you are familiar with that. Again, here it's really more if you are kind of going into complex analysis. If not, you can just discard everything I just said. Okay, before I go a bit more into detail into the intermediate representation, is there any question? Okay. Let's go over the intermediate representation. So what is an intermediate representation? It's a code representation that is usually used for code analysis purpose. So you can consider that, for example, Solidity is a high-level language used by human. You are going to develop your code in Solidity. SLITIer or intermediate representation goes a bit lower, and its purpose is to make the creation of code analysis simpler. To do that, we have designed our intermediate representation with a couple of things in mind. It doesn't have a lot of instructions, so we have less than 40 instructions. It's a linear intermediate representation. There is no jump, and the kind of control flow graph is based on the Slither control flow graph. In that sense, if you're familiar with intermediate representation, it's a hybrid intermediate representation. It's a flat intermediate representation in the sense that there is no nested operation. If you consider Solidity, you can have nested expression. For example, you can have an addition of an addition of an addition, everything within the same line, and this is nested. In SLITIer, everything is flat. So like if you have multiple operations, it's going to be split into multiple operations in that sense. We do a lot of code transformation, simplification. For example, in Solidity, you have a ternary operator. We are going to convert this into an if then else. Mostly just to, again, like the purpose here is to make the creation of code analysis simpler. So we have made a couple of choices in the design for that. To give you a quick kind of intuition in how like the intermediate representation looks like, we have binary and unary operator, like for example, addition. We have index for mapping access. We have member for structure access. We have a bunch of new operator. Here you can see, like, for example, we have a new structure operator, which does not really exist in a kind of explicit way in Solidity. We made it explicit just so that it's easier, again, to build analysis on top of it. Keep in mind that, again, this intermediate representation is not meant for people to read or to read. It's really more for the analysis to be easier to build on top of it. To give you kind of an example, if you have like this in Solidity, allowance of from of message at sender, and you decrease by value, this will create 3 operations, 2 difference, and 1 subtraction. Something to keep in mind when you're going to play with intermediate representation is that we have kind of a hierarchy in our class. This is just kind of a subset of all the operation. But you have here some representation where you have operation at the top, you can have a condition, you can have an operation with L value. I'm going to go over that in a few, and you can have call. Operation with L value, L for left, is basically an assignment. So any operation which inherits from this is basically going to be an assignment, like binary operation, member, high-level call. High-level call is basically an external call to another contract. So here it's a good example where high-level call is both an assignment, so an operation with L value, and also a call. In comparison to that, event call, which is the operation when you create an event, doesn't have any assignment, so it's just a call. Okay, now when you want to manipulate the intermediate representation, a couple of things to consider. The first thing usually to do is to check if the operation you are manipulating is based on a specific type. So you can use isInstance in Python to do that. For example, isInstance intermediate representation of a call. If you want to check, for example, if the operation is an addition, you first check with isInstance if it's a binary operation, and then you check its type to see if it's an addition. If you want to check if the operation is a call to my contract, again, the same, you start with isInstance, is it an high-level call, and then you check if its destination is my contract. Here's something important to consider is that every intermediate operation is going to have its own set of methods. So for example, destination, which we use for high-level call, doesn't exist for binary because binary doesn't have destination. So here it's important to go through the documentation for every operation you want to manipulate to understand what are kind of like the capabilities. To give you an example here, so again, like the first 5 lines are the same as before. We fetch a reality contract, we fetch the total supply function. Now we iterate over all the intermediate representation and we look if there is a high-level call. High-level call, again, is a call to an external contract. And if there is, we just print it. If we do that, we will see that, yes, there is a high-level call in the total supply function, and it provides like the source mapping. Something I went quickly over here is that if you look at the last line on the print and the kind of like the part in parentheses, you can see ir.node.source mapping. This is just kind of a shortcut that is going to allow you to map back the intermediate representation to the Solidity source mapping. So here you can see there is like tether token.sol and the line number. So this is usually useful if you start hacking on top of it to understand where it's coming from. There are a couple of features that are a bit more advanced. You probably won't need them, but I'm just going to quickly mention them so that you are aware. In particular, if you go through the source code, the first one is the notion of SSA. So SSA stands for static single assignment. It's basically another intermediate representation where every variable is assigned only once. This is really important for the internal of Slither. We use it to build some of the analysis, and it allows to create more precise analysis. However, it might not be kind of needed for you. Second thing I wanted to mention is that we do a lightweight alias analysis on the storage reference. So if you have, like, for example, a function with a parameter which is a storage, the storage, like the multiple variable might point to the storage, and we do an alias analysis to determine what variable can it be. So this, again, it's more if you start to play around with more complex analysis and you need to kind of determine like some complex pattern. Okay, before I go through the data dependency, is there any question? Okay. The data dependency is another feature that is a bit more advanced, but it is useful to understand that this is available. In particular, like if you want to think a bit more long-term about what can you build on top of Slither, knowing that this is available for you is probably going to be useful. Data dependency is basically a way for you to know if a variable is dependent on another one. Dependent means that its value is going to be related to some other one. In this really straightforward example, you have b, which is equal to a plus 10. So b is dependent on a. Now you can have things that are a bit more complex. For example, here you have b is equal to a plus 10, and then some condition, c is equal b. And you want to know, is C somehow controllable by the user? Is C something that the user controls, or is C something that is not controllable by the user? Slither provides an API for that. And we basically have two functions: is dependent, which is going to take a target variable, a source variable, and a context. I'm going to go over what is a context in a few. And is tented, which takes a target and a context. Is-tented is mostly like a shortcut for is-dependent against control variable, controlled by the user in the sense that any function parameter, message.sender, message.data. To understand why there is this notion of context, let's take this example. So in this contract, you have two variables, 1 and 2. You have two functions, direct set, which just set variable 1 to the user input, and indirect set, which set variable 2 to variable 1. If you just look at indirect set, if you just consider this, and you look at, okay, what are the dependency on this function? For variable 2, the only dependency is variable 1, which is straightforward. Now, if you look at all the dependency across all the functions from the contract, you're going to realize that because variable 1 is dependent on I and variable 2 is dependent on variable 1, there is a transition happening. So variable 2 is also dependent on I if you consider all the functions that can be called in this contract. And now if you use that back in the API of Slither, what is going to happen is that you can use, again, like for example, the is-tented function to know if a variable is controlled by the user, and you can do it in the context of indirect set or in the context of my contract. Here, if you run this, so you will kind of see that variable 2, is it controlled by the user in the context of just indirect set? No, because it's not directly controllable. However, if you do the same in the context of my contract, so if you consider all the function, yes, because the user can call direct set and can then call indirect set. Again, this is more useful if you start building complex analysis, but it can allow you to really kind of create tools and create analyses that are really more kind of precise and in depth. Okay, any question regarding the data dependency? Some of the most advanced detectors that we are building are going to use, like, for example, data dependency. Apart from constant, aren't all variables dependent on the user? It depends on the context that you are looking at, and not necessarily because, for example, you might have like a variable used to do loop iteration, which is not going to be directly controlled by the user. You can also filter out based on only owner. So, for example, some variables are only going to be controlled by the owner and not by a normal user. Some variables are going to be coming from other contract and not directly controllable by the user. There is also like nuance into what you define as dependent and controllable. Some variable, for example, like if you have a counter which is going to be incremented every time you do some operation, this is not going to be easily controllable by the user versus something where the user can just do an assignment to it. Okay. Where to start? So where you can start with all of that. One website that might help you is securecontract.com. So this is a website where we provide a lot of guidance and a lot of kind of guideline into how to build secure contract. We have tutorial for fuzzing and also for slither and program analysis. Through this website, you are going to see some of the API that I've described through this presentation, and there are a couple of exercises just to help you kind of get started with slither. If you clone slither directly and you go into slither tools/demo, there is a default folder with a couple of things and boilerplate code that might help you. It's going to create kind of like directly like a tool command line with argument parsing, just to make it easier for you to kind of start playing with it. Something I would highly recommend is to read the detector from slither, because we have a lot of detectors I mentioned, and they're going to give you some insight into the API, into what's possible, into how the API are used. It's going to give you also kind of a bit more insight into some of the flavor of how to build static analyzer. Okay, so slither on a high level is an open source framework to build custom analysis on top of it. What I would recommend is just try it out. Like I'm listing here a couple of examples of things that you can try to build. A bot that takes an address and show all the functions that don't have only owner, that can transfer asset. This is just going to help you kind of to connect together all the different pieces of the API that we saw through this presentation. Or maybe build a web interface that shows the storage layout on a deploy contract. Again, this is just to kind of play a bit with the API. The last example I'm giving here is to build a tool that provides a function, and from this function is going to show all the location where it can revert. Again, just a bit to play with the API and see what you can do. If you need help, we have a GitHub, so GitHub issue or GitHub discussion, and we also have a Slack more generally for any question with our tool or so. This presentation and all the rules for the hackathon are going to be in github.com/critics/ETHDam. Okay, any questions? I know that was a lot.
You did it. Yes, this is a highly technical workshop, but if there's any other, I can imagine that there'll be maybe other questions once people view also the workshop online as it's recorded, and that could happen. So I can imagine some questions there. And of course, people can come and bug you at your booth.
Yes, we will have.
Yeah.
That's a good point. We will have a booth during the hackathon, so don't hesitate to come say hi. There are going to be a couple of Trade-off Bits people walking around, so don't hesitate.
You have like a big fat T-shirt that people can recognize you and
We
They
have a
know.
couple of them. I don't know how recognizable it's going to be, but yeah, it's going to be Trail of Bits on the back. So
Good.
might help.
Suited up so that people know who to bug and find you in the crowd. So yeah, really cool. What else can we say? Like as you already mentioned it, but of course you're going to put everything in the Discord and so
Yes.
people can find everything. And yeah, I think that's it for you. Is there I'm looking at the chat. What? We won't be following Trail of Bits like Crypto Hansel and Gretel.
That's really
That's
good.
a good one. That's
I'm
a
going
good
to steal
one.
it.
Yeah, that's very cute. What about some snake stuff? Do you have some Slither merch? I immediately, when you started talking about I want to take out my Slytherin, mug that I have my Harry Potter Slytherin.
We definitely should have some.
Yeah, some little snakes on the booth, like some fake snakes.
Some
Like,
fake snakes.
what is this? No, this is a Trail of Bits booth, or is it, the jungle or the mythology of it? It would be super fun.
One of our tools is called Medusa, so it's also a good connection.
Nice. Very nice. Yeah, exactly. Hogwarts theme confirmed. Yeah, you guys just need to get some little like Harry Potter hats or something. Wonderful. Well, thank you so much, Jocelyn, for doing this wonderful workshop, for participating in the ETHDam bootcamp. As mentioned earlier, I'm happy to stay online and facilitate some team building, or if anybody wants to just, I open the stage to everyone really to get to know each other, or if there's any questions, or if people are already like thinking of what to build, this is your moment. And
before ending, I also want to say thanks to you for the organization. Really looking forward for this event and yeah, meeting everyone.
Yeah, it's gonna be fun. Thank you so much. All right. Are you guys too shy? Is someone gonna take off their no, people are just like, I got the info, I'm out. That's also very fine. Just keeping in mind that tomorrow we have the OASIS